Dr. Olivia, glad to have you with us here today. Where are you calling in from?
Hey, Jared. I'm glad to be here. I am calling from the East Coast in Virginia.
All right, East Coast, no effects from the hurricanes where you're at. Are you far enough north?
We were fortunate to not have any damage. Very thankful for that.
Cool. Well, that's good. Well, we'll jump right into your presentation. We're grateful that you're here with us.
Thank you for having me. Hi, everyone. My name is Olivia Caillouet, and I am a soil health program manager at the University of Missouri Center for Regenerative Agriculture. We affectionately call that CRA. I'm really excited to be part of the Regenerative Legacy Summit and discuss cover crops and the impacts on soil health. This presentation is one of 11 training modules on cover crops that are available for you, free to download. I think Margot will share a link to that towards the end of the presentation. You can also access the modules at cra.missouri.edu. And I'm excited to follow Jimmy's presentation because I think a lot of the things I'm going to touch on complement what he covered really nicely. We're used to determining progress with crops by what we see above ground, but with soil health, it's really all about what's happening down in the soil out of sight. We have a lot to cover, so I'm going to go ahead and dive in. This presentation will cover 10 specific ways that cover crops impact soil health and how cover crops influence farm regeneration and legacy. Because of my screen view, I'm actually unable to see the chat, but I'm going to try to leave time at the end for Q&A. And Jared, chime in and pause me at any point if needed.
Will do.
So first off, cover crops feed the soil food web. One of cover crops' most important contributions to soil health comes by providing living roots for a great portion of the year. That could be a cover crop like radishes, pictured here, or other plants that provide living cover at time of the year when cash crops are not being grown. You may have seen a diagram of the soil food web like this one. While this is a very simplified view of the complex web of life in the soil, it does help illustrate some of the connections taking place. Two key categories I want to point out are the soil fungi and the soil bacteria. Both play major roles in exchanging nutrients with plant roots and helping to break down that plant residue and build that organic matter. Healthy soil in a field can contain as many as 600 insects right beneath your shoe. Tilled fields with bare soils have been a common sight in crop fields. However, we've come to learn that bare soil with no living roots makes for a tough environment for soil life. Imagine going to the grocery store in November and being told there's no food available till April. That's a rough equivalent to what soil microbes are facing when we leave fields barren from fall to spring with no living roots to help support that food web. Another way to picture this is an analogy. Jerry Hatfield, a director of a major U.S. Department of Ag Soil Research Center, calculated that the amount of biological material needed by soil organisms in 1 acre, which is roughly half a hectare, is similar to what 2 big African elephants would eat. So in other words, that's a lot of biomass that those soil organisms are needing. Another analogy for cover crops is to solar panels. They can work for us year round, and we want our crop fields to do that too. Some innovative soil health focused farmers talk about how they want to take advantage of a free resource, namely sunlight, by having living plants out there to capture that sunlight and convert it into organic matter and generate improvements to their soil health. Number two, cover crops increase earthworms. Earthworms are one of the most visible aspects of soil health changes that may be stimulated by cover crops. And research has shown that earthworm numbers do increase in fields with cover crops compared to fields without. There are three main types of earthworms that occur in fields, especially where tillage is minimized, and cover crops provide more of a food source for these earthworms. And along those same lines, a green cover crop is noticeably different than seeing a tilled conventional field, but it's below the soil where these differences are even more apparent. A tilled soil will be uniform on top and may have a restricted root zone at the bottom of that tilled area, pictured here on the right, known as a plow pan. Moreover, the tillage destroys macropores, which are channels created by earthworms and crop roots, including cover crop roots, that allow that rain to infiltrate the soil more quickly and help with root growth as well as gas exchange. Number three, cover crops build soil carbon and organic matter. And when I think about legacy, Dan DeSetter comes to mind. This is a photo of Dan, who farms about 5,000 acres of corn and soybean and grazes cover crops with beef cattle in west central Indiana. Dan has frequently stated that one of his goals before he stops farming is to rebuild or restore his soil carbon and soil organic matters to the level near what they were at when farming first started in Indiana. A big part of Dan's motivation is his three sons, all in their 20s, that are farming alongside him, and he wants to leave the land in better shape for them. This is a figure from a soils textbook used in undergrad classes in the US called The Nature and Property of Soils. And in the short, the diagram depicts how, on average, half of the soil organic matter has been lost from cultivated soils in the US, which is that green portion. The good news, however, is that the soil organic matter can be rebuilt over time when the active organic matter rebounds, first when cover crops are implemented, that's shown in that light brown section, and then over time, that passive organic matter, the more stable fraction in the dark brown, will gradually start to rise as well. A simple way to visualize a key benefit of soil organic matter is to think about a sponge versus a brick. When we have that higher pore space and lower bulk density of soil with improved soil organic matter, it makes it more like a sponge, better able to soak in and hold on to water from rainfall events. The higher levels of soil organic matter also improve crop rooting and feed those soil organisms that have long-term benefits for overall soil nutrient availability. Number four, cover crops help manage soil nutrients. This is a photo of crimson clover blooming in mid-spring. Now, crimson clover is the most popular legume cover crop in the US, but it is best suited for the southern half of the country since it doesn't reliably overwinter in northern areas. Overwintering means what it sounds like, the ability of a plant to survive the winter and continue growing into the spring. In past years, there was some thinking that nitrogen fertilization could be viewed simply as an input-output approach. For example, put on an extra pound of nitrogen per acre for every extra bushel of corn you expect or hope to gain. But now we realize that nitrogen cycling and nitrogen management are much more complex than what's illustrated here. And this is even what I learned in undergrad. Even though this diagram seems complex, it illustrates just part of the actual complexity of many different types of soil organisms interacting with plants and the soil to affect nitrogen cycling. Of course, legumes can fix nitrogen in conjunction with symbiotic bacteria, but we also have free living bacteria that can fix nitrogen and other bacteria that cause nitrogen to change forms, including denitrifying bacteria. Overall, a healthy community of soil organisms will help nitrogen and other nutrients stay in our root zones rather than leaking out of the system, either leaching into groundwater or going into the atmosphere or running off the soil surface in large rainfall events. Cover crops have also been shown to scavenge leftover crop nutrients at the end of the growing season, keeping those nutrients in the root zone until they can be used for next year's cash crop. Number 5, cover crops keep our soil covered. And this is one of the Natural Resources Conservation Service principles of soil health, is to keep our soils covered at a minimum with plant residue, but ideally with those living plants. Increasingly, farmers are letting cereal rye grow fairly large ahead of soybeans, sometimes even 4 to 5 feet tall. In some cases, the rye is rolled before planting soybeans, but more often, farmers are getting confident planting soybeans directly into standing rye, with the planter knocking down much of the rye. The rye mulch helps control weeds, and the residue from cover crops can help moderate soil temperatures, keeping it cooler, especially until those cash crop leaves shade the row completely. The cooler soil temps help with our soil microbe function and reduce stress on our cash crops on sunny days. Ultimately, cover crop plants and residue can help with our moisture retention and even trap in snow. I love this phrase, the soil is meant to be covered, because I think it helps remind us that the soils we farm were always covered by living plants in the past, whether it be prairies, like pictured here, or forests. Thus, those soil microbes that we depend on for soil health have evolved in conditions of year-round plant cover and living roots. Those microbes and other soil organisms are not as adapted to our modern farming approaches of just having living crops for 4 or 5 months of the year with bare soil for the other 7 to 8 months. Cover crops, while not providing as much diversity as a native prairie, can at least help provide living roots and cover year-round. Number 6, we highlight cover crops add biodiversity. If we can get more biodiversity, either through cover crop mixes or at least rotating a variety of cover crops over time with our cash crops, it helps improve overall diversity and soil organisms. More biodiversity in the soil helps with farm resilience to pathogens and pests, and as we've discussed, more effective nutrient cycling. In cover crops with just 1 or 2 cash crops being used, it's especially important to try to add cover crops so that we can increase that on-farm plant diversity. Here's an example of a popular cover crop mix of crimson clover, hairy vetch, and cereal rye. One of the key soil organisms that cover crops can help support is mycorrhizal fungi, and that fungi is associated with plant roots, including cover crops as well as cash crops. The plant roots release carbohydrates that are taken up by the fungi, and in return, the fungi can supply nutrients and water to the plant roots. The fungal hyphae often spread throughout a larger soil volume than our crop roots, which give our crop roots a greater access to supply of nutrients and water. This is especially helpful in dry years when crop root growth might be limited. Number 7, cover crops get rain into the soil, and you've already seen a similar example of this rainfall simulator, but the idea being when we have cover crops, we have more water infiltrating through these perforated trays into that back jar. The cover crop is that center tray, in comparison to that bare tilled soil directly to the left, where we have that soil running off into that front jar. This is even more apparent when we flip those trays over. We can see that that front tray, the tilled bare soil, has no water infiltration. And that's because when water hits that bare tilled soil, it actually creates a seal. That seems counterintuitive because you'd think loosely tilled soil would be able to soak up the rain, but this is actually what happens in most silt loam or clay loam soils. Whereas with that cover cropped example, we have rainfall soaking in due to those macro pores created by earthworm tunneling and cover crop roots, leading to better soil aggregate structure. And that will really help in large rainfall events to avoid soil ponding and help farmers get into their fields more quickly. Number 8, cover crops reduce compaction. Now, cover crops can't fix the type of severe compaction caused by this tractor, but they can help prevent the situation. And we've heard that term soil aggregates, and that's synonymous with soil building blocks. We need 4 main things to enhance our soil aggregate structure, and that includes minimal or no disturbance of the soil, which goes hand in hand with our reduced till or no-till practices. We need organic matter to be available, which can come from cover crop residue, both above and below ground. We need those fibrous roots that contribute to that aggregate formation. And we need mycorrhizal fungi, if at all possible, that can aid in the formation of aggregates by releasing a type of soil glue. So we need to ask ourselves, which is less expensive? As we see in this equipment photo, the normal response to soil compaction has been to get a high horsepower tractor and go out with some type of soil ripper. This can provide some temporary relief from soil compaction, but we find that our soil slits will swell back together in a year or less. And using this type of mechanical approach comes at a high cost of equipment, fuel, and labor. Whereas cover crops have been found to be a more affordable option for reducing compaction in a multi-year study by Ohio State University. By building soil aggregate structure with our macro pores, cover crops can help provide long-term solutions to soil compaction and reduce the chances of it happening in the future. Number 9, cover crops support the integration of livestock with row crops. More and more farmers are realizing the benefits of reintegrating livestock into their crop fields, typically by grazing cover crops. The manure, urine, and saliva from grazing livestock has been found to stimulate soil biology and improve overall soil health. Grazing cover crops can be a very profitable management approach, as the cover crops can provide high value forage at a time of year when other forages and hay may be in short supply. And animals that are grazed on cover crops can be healthier than those in a feed hay, animals fed in a dry lot, and spring calving can also be improved. Along those same lines, we see cover crop grazing become more accessible with portable fencing, water tanks, and we're seeing the development of virtual fencing technology as well. We want to keep in mind that our soil microbes have evolved in systems that had foraging animals historically, whether it's the buffalo in the prairies or deer in the woods. Soil microbes perform best, leading to healthier soils when animals are a part of our farming systems. And number 10, cover crops help stop erosion. With bigger and more intense rainstorms many areas are getting, soil erosion is a very large concern. Past approaches of building terraces may no longer be sufficient, but planting cover crops and using no-till or strip till between terraces can dramatically reduce our erosion by 90% or more. There's an example of those best practices being implemented. Cover crops can reduce water erosion by living in dead cover crop leaves, intercepting raindrops. We can get better water infiltration, and those cover crop roots can anchor the soil and the residue in place. Cover crops can also reduce wind erosion. Even just a little bit of cover crop growth, as seen in the bottom right photo, can stop wind erosion from happening. To highlight the importance of cover crops, the most biologically active and nutrient-dense part of the soil profile is in our top inch. So by saving that portion of the soil from erosion, we are ensuring that that upper layer can be maintained and improved for continued soil health. The bottom line is that cover crops are a very unique agronomic tool, similar to a Swiss Army knife, that can provide a variety of benefits towards improving our soil health. And I'm not going to go through each one of these again, but this is a recap of the 10 ways that cover crops help with our soil improvement, farm resilience, and you can learn more about cover crops through SARE, which is SARE.org/cover crops, as well as the U.S. Regional Cover Crop Councils. And with that, I'll highlight those 11 cover crop training modules I mentioned earlier that Margot will share in the chat. You might also want to check out the Living Soil documentary by the Soil Health Institute. And with that, thank you again for this opportunity to be a part of the Regenerative Legacy Summit. Very grateful to be here, get to learn from other speakers. If you'd like to learn more about the University of Missouri Center for Regenerative Agriculture's work, please contact me at oliviacaillouet@missouri.edu. And if we have time, Jared, I'm happy to take any questions.
Yeah, you bet. Thank you, Olivia. That's great. It's a great overview of the value of cover crops. I first heard about cover crops probably about a decade ago. We're not farmers, and it was actually from a rancher. Somebody had heard Gabe Brown speak in Idaho, and I just started learning about it, and then actually took my then, what was he, 17, 18-year-old son, and we drove to Colorado to hear Gabe speak and Ray Archuleta. And that was really like what boosted my journey into soil health. And while I can't say that I have successfully integrated cover crops into my perennial pastures, maybe Colin Seiss tomorrow is going to tell us how to do that. I can absolutely say the principle of biodiversity works. So with that, there's a question, Dr. Olivia. Somebody asked with biodiversity, I'm growing grass for forage. Why do I want voles and moles? We get that they're breaking up the soil, but they're also creating bare patches, and their tunnels are destructive. Any thoughts on that, on some of those things that we might see as rodents that might actually have a place in our ecosystem?
Yeah, Jared, that's a really great question. And I'll plug those training modules again because one of them is actually on pests. And I think the main takeaway with that is you don't have predatory birds if you don't have rodents. And there's a balance there where I completely understand the challenges of voles and slugs and that threshold where it becomes overwhelming. But if we can find that natural balance of creating predatory bird habitats to help manage those pest populations, I do think and strongly believe from the farmers I've spoken with that nature will find a balance there.
Yeah, I definitely echo that as well. Something that we learned in the Savory model of holistic management is Is Tony still on here? I might get this completely wrong, but you need to ask what we need to add, not what we need to take away. I think that's the principle. When we see an excess of something, we tend to say there's too many moles of voles. We've got to remove them. No. And you pointed it out. What do we need to add? The predatory birds. So super good.
Great question.
Can next question here, can cover crops in hillsides slow down flash floods into the valleys?
Absolutely. And, you know, I would say that the tools, the cover crop species selector tools, can be a great guiding resource for identifying which cover crop species can help best with soil erosion prevention. So that's what I would highlight, would be honing in, okay, you have identified your on-farm need. That will help make cover crops pay for themselves. Now we need to identify which cover crop species will help best meet that need you've identified.
Yeah. Yeah. So water infiltration is huge. One of the biggest benefits. And then another one, and this is my question too, because I've tried a lot, planted thousands of pounds of cover crop seeds, and not all of them have grown. But do we put cover crops in pasture? So I'm assuming in perennial pastures, do you have any keys or guidelines for implementing cover crops? And maybe even the broader question, are they necessary in a perennial pasture?
That's a great question as well. I will say I don't have as much experience with perennial pastures. Over the past year, I've been working a lot with row crop producers. I will say that I see many soil health benefits when we have two or more species growing. So that's where we can see a lot of carbon sequestration, improved soil health, is if we have even a little bit of plant biodiversity. Now, I'd have to look to some experts as to which species that would be, but that would be my initial take.
Yeah, yeah, I'll echo that. And the challenges that we've had are, we've attempted to integrate cover crops both in dryland situation and in irrigated fields. The perennial pastures are so tightly sodded that doesn't create a good environment for them to grow. There's a lot of competition, and so there's definitely some challenges there. Somebody just dropped in the chat the other, and maybe after, if you want to respond to any of these questions that might not have been answered, you're sure welcome to stick around. But is there a link to types of tools, cover crop selection tools, things that you want to recommend, and drop in the chat there? That would be good, and encourage y'all to copy and paste and kind of save these things. One of the things that I like to do when I'm taking notes is I'll usually have a Google Doc opened. When somebody's given a presentation, I'll take screenshots of the slides that I want to remember, take my notes beneath them, and then if there are relevant links, just copy and paste those. And then you've got it all in that Google Doc. You can title it Regenerative Legacy Summit, October 24. And then when you're going back and you're researching, you can pull that up for that, and it's kind of a way to be able to store it. So, okay, well,
Great
with that,
thoughts.
we better wrap up. But Olivia, any quick final thought that you have for us here before we move on to our next speaker?
Always learning, and don't be afraid to make mistakes. I think that is one of the best ways that we learn.
Absolutely. Yep. Gabe Brown
Thank you
says
for having me.